Hello, we are MEDIBlog. Today we're going to do something very unusual and quite interesting. As you can see from my gloves, we're going to be doing something quite out of the ordinary. Yes. We are going to be doing a brain dissection. We can see this sheep's brain, as you can see it here. And we're going to be using this to demonstrate the functions and different parts of our brain, as they're quite similar. They're just the only difference really is the size between a lamb's brain and a human's brain. But obviously we can't get a human's brain for obvious reasons. So we're going to be showing you different parts and their functions of the brain using this sheep's brain. We hope you enjoy it. Thank you.
Even without dissection, we can see some features.
From this view, we can see the brainstem here, the right and left hemispheres of the brain, the cerebrum, and the cerebellum, which is the little brain here. Notice these grooves with the scientific name sulci and ridges with the scientific name gyri.
Impulses reach the brain through the brainstem. The brain acts as the coordinator and sends impulses back to affected organs, which carry out a specific action, whether that be the contraction of a muscle or the secretion of a chemical.
The cerebrum and the cerebellum may have similar names, but they have very different functions. The cerebrum makes up about 85% of the brain and is much smaller in the sheep than in an actual human. It is where higher order of thinking takes place. In other words, this is where you do your analysing, evaluating and planning. All of this area here, cerebrum. The cerebellum, which is right here, which is called the little brain here, is located just above the brainstem. Notice how folded it is to increase the amount of surface area. This is to increase the number of nerves contained in this small space. The role of the cerebellum is to control muscles and coordinate movement. If this section of your brain were injured, you might have difficulty walking, standing, or moving your body parts.
A common way to separate the brain is by its two hemispheres. This is because both hemispheres have different uses. The sheep's left of the brain is the logical side, which is responsible for the ability to read, write, and do languages. Obviously, the sheep won't be able to do this, but this applies more for our brains. The right side of the brain, the sheep's right side of the brain, is the creative side of the brain, which is more involved with the arts and music.
The base of the brain also has many features that are essential to us. This is where any nerves would connect to the brain from various parts of the body.
You could very clearly see the olfactory bulbs, which are present on both hemispheres. These will connect to the nose by nerves to control the sense of smell.
Also connected by nerves would be the optic chiasm here, which is this X here. The optic nerves from each eye would come in and get processed in this X here, as you can see.
If we look carefully, we may be able to see an optic nerve.
This is it, where it would come in. Here. These are the beginnings of the optic nerves, the two. And then they get processed here, in this X. It's called the optic chiasm. We can also see the medulla, which is this bit here. This sends and receives impulses to the mouth and lower body, and by doing so effectively controls them.
Now we will be dissecting the brain in half to observe its inner components. Many of you may have heard about the pituitary gland already. This is because this is an essential part in many processes in our body, such as the regulation of our salt levels, and in women, the menstrual cycle. These processes all involve separate hormones which are secreted from this.
The pons, too, acts as a bridge between the medulla, which is here, and the upper brainstem here. It also relays messages between the cerebrum and the cerebellum.
This is the cerebellum cut in half. This allows us to see this branching structure here. You can observe here a lighter tissue and a darker tissue. The lighter tissue is called white matter, and the darker tissue is called dark matter. White matter carries impulses to the dark matter, which is made up of nerve cells, which process the information and sends impulses back to effector organs.
We hope you've enjoyed watching our brain dissection and learned a lot about the anatomy of the brain.
If you want to learn more about medicine, go on www.medibloguk.com, where we post new articles every week.
Thank you.